Okay, this lecture is on series and parallel connections. It says great things are done by a series of small things brought together, and there couldn't be a better quote for something that's connected in series electronically. So the key thing is there are multiple pathways or there are not multiple pathways. That's the whole key to distinguishing between a series and a parallel connection. So the goals, you should be able to distinguish between a series and a parallel connection based on the connectivity of a component. So I should be able to show you a picture or a circuit diagram, and you should be able to say, hey, that's in series or that's in parallel. You should also be able to describe the brightness of each bulb for a series or a parallel connection. And then you should also understand the role of a circuit breaker and a fuse and how they are different. Okay, number one, we're looking at series. A series is a combination of resistors or anything in which there is no alternative but to go through both of them. So you can have any number of resistors in series, but for example, when I leave this end of the battery and I come through, I have to go through this resistor in order to get where I'm going, and I have to go through this resistor. Since I have to go through both of these are said to be wired in series. In fact, all three of these are actually wired in series because I have to go through this one and this one and this one to get to where I want to go. Same thing with this one. You see this as a diagram, or excuse me, it's kind of a picture more than a diagram because you see this, I go through here, I have to go through these in order to get to the other end of the battery. So series explain. Series circuits are kind of like a one-lane road. If you have an accident or something along those lines on the road, what happens is everything that's on that road, everything that's behind that accident, will all come to a stop as well. All the cars are moving in the same direction, they're all moving at the same speed, and so when all of a sudden one car is stopped, the whole line of traffic stops as well. So a series circuit in action. Series circuits are actually very, very useful, especially because if one connection goes out, they all do. So they're very useful with fuses and circuit breakers, number one. A fuse or a circuit breaker is wired in series with everything else that's on that circuit, so that if you have an overload or excess current in one particular thing, like an outlet that you have a hairdryer plugged into, the fuse or circuit breaker will trip and it will turn everything off that's there. The other thing that's nice about a series circuit is it actually allows you to manipulate voltage very well. If you can manipulate the voltage, it has uses that we'll talk about in a little bit later. But in series, it's very important that you understand that the voltage drops for every resistor in series. So the voltage is different for every single resistor in series, provided they're different resistors. And so that gives you something that you can use that we'll talk about a little bit later. And then number two, the resistance actually adds up. Whenever you have resistors in series, as you add more resistors in series, the total resistance of the circuit goes up. The current is the same no matter where you are. And regardless of the resistor value, any resistor wired in series will have the same current no matter what. And that has to do with the law of conservation of charge that we talked about earlier. No matter what, you have to have the same amount of charge that you had to begin with. Parallel. Now a parallel circuit is one in which you have a combination of resistors in which there's multiple pathways in order to get where you want to go. For example, if we take a look right here, when I go from this end of the battery, I can go this way, and I can go through this light bulb to get to the end of the battery, or I can go around it, and I can go this way. So these two light bulbs are said to be wired in parallel because I have a choice of going through either this one or this one. So you can sum up and say any two resistors that are wired in parallel are such that there are multiple ways or multiple lanes to get back to the battery. So parallel is like having a highway or multiple lanes or multiple different roads to get where you want to go. So the cars are all moving at different speeds, but they're all going the same place. Everybody on this highway is going to the edge of this place over here. These are going to be going slower than these are going faster. No matter what, they're all going in the same direction, but they're all moving at different speeds depending on what lane they're actually in. If an accident happens in this lane, it's not going to affect too much the electrons or the cars that are in this lane because they can continue to go along their path. Same thing is true with parallel. If you have a break in one part of the circuit, it doesn't break the other part of the circuit. So a parallel is particularly useful because the voltage stays the same. It is useful because if one resistor goes out, the others stay on. So for example, if I flip the light switch off in my room, that doesn't automatically turn off all the outlets. It doesn't turn off the air conditioning in that room. It doesn't turn off all the other things that are wired on on that particular circuit. So the fact that they're in parallel is very nice because it allows you to have some things on and some things off. Also, it's very important because the voltage is the same in each. It doesn't matter where you plug a device into your house. You're going to get the same voltage whether you plug it into the top, plug it into the bottom, plug it into a different outlet altogether, as long as the outlet is the same. There are a couple of different outlets in your house, but we'll talk about those a little bit later. It is very important that you realize that the current is different in each branch, so that's also going to be useful as well. And when you add resistors in series, when you add resistors in parallel, the resistance actually goes down. And the reason why, we'll go back to our example we had here. If you add extra lanes here, you're actually going to allow more cars to get where they want to go faster. We talked about fuses and circuit breakers real briefly already. You need to realize that a fuse or a circuit breaker, a fuse is not reusable. And so it's somewhat expensive because it has to be replaced instead of just reset. All houses that are down here now that are newer construction have circuit breakers and not fuses because they can just be popped back on. Now, a fuse or a series has to be wired in series in order to be effective. In fact, if you were to wire a fuse or a circuit breaker in parallel, it would create what's called a short circuit and would automatically melt, or the circuit breaker would trip. So hopefully now you can distinguish between a series and parallel connection. Hopefully you can describe the brightness of each bulb for a series and parallel connection, and you're actually going to get more help with that in the lab that you're going to do. And then hopefully you can understand the role of circuit breakers and fuses and how they have to be wired and what their function actually is.